Okay, I will try to do it without my keyboard. Hopefully, I will be able, though it won't be really easy. But without further delay, let's start the talk. So today I would like to tell you how it is to write Scala outside of Intellij. And first of all, I'm very happy to be here and excited about what I am going to show you. A little bit about myself. So I work as a software engineer at Input-Output Global. I'm also really into mechanical keyboards, but apparently something must have broke. I will need to debug it at home. I'm also a Linux and terminal applications fan. And I've been a long time Intellij Idea user. I've been using it for most of my professional career. And last but not least, I also enjoy working at making the developer's experience better and tooling. Because I really think that if companies had spent more money on this, our society would already look like that. Okay, so what are the goals of this talk? First of all, I want to show you that it is actually possible these days to have a good experience with writing Scala outside of Intellij. And it can be something even as exotic as Neovim. And using such an editor can be, in some places, even better than the Intellij. But before we jump into using Neovim with Scala, I want to mention about two projects without which that talk wouldn't be even possible. First of them is Language Server Protocol, LSP for short, and I'm pretty sure that many of you have already heard about it, because that's how the Metals communicate with, for example, VS Code or whatever editor you use. However, for those who don't know, I will give a very brief introduction. So LSP solves a very particular problem, meaning that on one side we have multiple editors, and on the other side we have multiple languages. And now, whenever you want to add new editor, you have to add support for many different languages to it, and this is just a lot of duplicated effort and work. And on the other side, when you create a new language, you also need to code support for it into multiple major editors that are out there. So LSP solves this problem because it's a standardized protocol that tools like editors can use to communicate with language servers, which are components built to serve semantic information about code base in a particular language. And for Scala, we have this awesome language server called Metals. Right. And the other project that I want to mention is Tricitter. It may be a little bit less known for many of you. So Tricitter is an incremental parser generator. From one side, we feed it with a grammar of our language, and on the other side, it gives us a very fast and robust incremental parser written in C. And because this parser has a C API that's very standardized, actually on a very high level, both projects, Tricitter and LSP, can be shown using similar images, because thanks to the Tricitter, we can, right, I should have mentioned why we use the Tricitter in the first place. So you may not know it, but you use Tricitter every day probably, because GitHub uses Tricitter to provide syntax highlighting when you are browsing GitHub repositories. And that's the major use case for Tricitter, although not the only one. So we can use Tricitter to write the schema for your language once and have the parser generated for it, and that parser can be integrated into multiple different editors, which will have a very unified experience of highlighting a particular language. Right, so with those two projects, you basically are open to many different editors. However, I chose Neovim, and now you may wonder why. Well, first of all, Neovim is a fork of Vim, so it's building on top of all those years of experience that authors of Vim gathered throughout the years. And Vim is really like an awesome text editor, but it's only a text editor. And of course, code is a little bit different than text. Code has a structure, it has semantics. However, I will try to show you today that you can extend some editing capabilities of Vim to also work on the code. It is also end-user scriptable, so the whole configuration of your Neovim is written in Lua, and you can also write some small Lua snippets to extend it further or customize, which is really cool because you get this configuration as a code like for free, meaning that you don't need to hack anything. It's just like this. And by end user, I mean that it's really simple, so simple that an average Neovim user is capable of doing this, which is like, I'm pretty confident to say that it's not the case for Intellij. Sure, it has plugins and you can extend its capabilities. However, it's not that easy to write plugin on your own. Neovim also runs inside terminal. It doesn't have to, but by default it does. And this is quite important for me, because you see, at the beginning of my career, when I saw Intellij, I thought, oh my God, this it's so powerful that soon we won't need any other tools. We'll just bring everything into Intellij. Well, you know, in the end, IDE stands for Integrated Developer Experience, so it makes sense. However, over the years, I started using terminal more and more, and that has probably also because of Fuzzy Finder, which provides incremental capabilities into your terminal. However, recently I thought that if I cannot bring everything into my IDE, maybe I will bring my code editor into the terminal. So that's why Neovim. It has also awesome and thriving community, and I have some slides later to support the thesis, but generally I think that it's because Neovim is not really specific to Scala. It's like general purpose editor, and people from many different languages contribute to it and share ideas how you can improve your workflow. And I think that it is what it makes that awesome. Neovim also follows Linux philosophy of modularity and simplicity. And this is really important because like simple and modular tools compose. And when you compose multiple tools, you can have really great results without reinventing everything from the ground. And like the prime examples of those are like Tree-Seater and LSP. But for example, when you grep for a text in your project, Neovim will actually call some binary like grep to provide you with the results without re-implementing this on their own. Neovim is also one of the most loved editors. Actually, is the most loved editor according to the Stack Overflow survey from the last year, just in front of the Visual Studio Code. And you know, I wouldn't choose an editor that does not have an ecosystem around it. However, that's not the case for Neovim, because there are more than 6,000 public repositories that has a Neovim topic attached, and I'm pretty sure that many of them are just Neovim plugins. But I also think that it's fair to say that there are more plugins than that, because some plugins may not have this tag or may not even be on a GitHub. And according to the Google Trends, the Neovim popularity has been on increase. over the recent years, and I think that this trend will continue as more people will come from Vim into Neovim, and maybe also from other editors. Okay, so now goes live demo. I already don't have my keyboard. I will try to do my best to show you what you can do, but it won't be easy. Hopefully the guts of live demo won't do more tricks on me today. Okay, let me... Is it good enough font, or should I increase it? Okay. I won't do more, because then I won't see anything myself. Let's also try to run this one. Okay. And oh, wait a second. We need to do some special incantation. Okay. Right. So now let's jump to some Scala file. So I tried to prepare for you some scenario which would reassemble, like to some degree, things that you do during your normal day. I'm not sure how well I did it, but hopefully you will be able to somehow relate to that. Okay, so now this is like a Bootsuka code base. However, it has been simplified a lot, but I still wanted to keep some file to like make it more realistic. Okay, so we are going to user validator class. Right, this one. And as you can see, we have this syntax highlighting that is provided by the tree-seater. And in the bottom right corner, we see some logs from Metals that is running in the background. Maybe they are not logs, but some informations that it's compiling our file. Okay, before we do anything more complex, I want to quickly cover like some very fundamentals of Vim. So in Vim, you have those motions. And one of the very first motion that you learn is W, where you can jump to the next word. And and you can use also capital W to jump over the white spaces to the next word. And you can use B to jump backward. Okay. You can also combine those motions, like there are many more than that. You can combine them with comments, and for example, such a command is D, which stands for delete, and now I can combine it with motion, so DW, which will just delete this word. Now I will press U to undo the changes. However, those are text-based motions, and when we work with the code, sure, we sometimes may want to use those text-based motions, but usually it's much easier to operate on the code structure and not on particular words. So for that, I can use tree-seater, and it specifies some text objects that are created based on the tree-seater nodes. And for example, here I have a text object bracket m, which moves me to the beginning of next method. And I can also repeat that motion with semicolon. I don't know where it's semicolon on this keyboard. Okay, here it is. And I can move backward using that motion with a comma. Okay, so this is how you move between methods. And so you can also combine this motion with some commands. So for example, if I press D and bracket M, I will delete this whole region up to the next method. There are multiple text objects defined in tree-seater. However, you may want to create your own text object, and it's really not that hard. So one of the things that I really liked in IntelliJ was the Command-Shift-A, like search over all the options that are possible. And we have something similar in Neovim. So I can press leader slash, and I have this interactive menu where I can search for commands. I will search for three-seater playground toggle, which will open me in a split view a three-seater representation of the current file. And now we can see that whenever I move in the file, I also see which node is currently highlighted. And the same goes the other way. Wait, how do I switch buffers here? OK. And now, if we want, for example, to move from one field of a class onto the another, like for now there is no such text object in three-seater, but we could easily write one for ourselves. So I can press O, which will open me a query editor for three-seater. And oh, wait. Let's check how this node looks like here. So this is a val definition, which is inside a template body node, right? This is a template body. This is val definition. So we can write something like and this is a query that will match on every single field in a class. And as you can see, it's matching those two on the right side that are highlighted. And now I could integrate that query into my workflow if I wanted to, and have some integrated also into the whole ecosystem of Neovim commands and motions. OK, so that was a three-seater. I can also perform some other edits using three-seater. Like, for example, I can swap parameters in a class. And this is also based on the three-seater nodes, so it won't break any syntax. And I can also get it back. OK, so now once we covered those basic motions, we can jump, for example, to errors. And I have opened this error tabs here, which can help me navigate to where the error is. Let's now turn off this error tab. And here we see that we do not have our code does not compile. So we can navigate to this comment section. And using incremental selection, again, something that is that I really liked from IntelliJ. We also have it in Neovim, thanks to the three-seater, but also Metals supports it, so you can actually have it in every editor. I can expand the selection based on the three-seater nodes, but I also can shrink it. OK, let's write down this code. So we'll use a printer here, and printer. OK, yes. Now I have code completion, and as you can see, apart from code completion, I also have the Scala docs. And if I press Enter to confirm this choice, you can also see that the import has been added at the top of the file. And we will use no space printer, and we will also copy it to set drop null values to false. No, I wanted to use true. And because three-seater knows that true and false are logical Boolean literals, it knows that the false is opposite of true. I can actually flip it to the opposite value, and this flipping or increasing works not only on Boolean values, but it also works on integer, dates, versions, and so on and so forth. Okay, now once we fix the code, we can actually save it. And because of how metals integrate with Neovim, it will, I'm not sure what it will compile right now, so I will just, to make sure that everything is compiled, I will call metals, compile cascade. Yes, now the code, the whole project should be compiled. So we can navigate to the diagnostics, and for example, here I'm using bracket D motion to navigate to the previous diagnostic or to the next diagnostic, and it can also be repeated as with the motions I told you before. So now we can invoke code action to fix those unused import, and we have actually a nice preview what will happen when we apply this code action. We can scroll it down a little bit to see what will be the end result. Okay, let's save this file. What else we can do? So now I will now we'll move to the user validator spec. Okay, and this is a test file, and as you can see, it has those virtual text on the right. So we can actually invoke, those are called code lenses, and we can invoke them just directly from Vim. So we'll try to run those tests. Okay, we can see that 6 tests passed, but actually there is one test that is commented. So let's uncomment it, and here I will use again like power of tree-sitter to uncomment it, because tree-sitter knows how block comments looks like, and it can uncomment every language that it is aware of. So in this case, it will be GB. Now let's run this one. So CL and test case. And as you can see, it failed. So we'll try to debug it to see what happened. So I will press now CL and debug, but wait, first we need to set a breakpoint. So DT and another one here, DT. So now you can see that on the left side we have set some breakpoints. So let's run our test, CL debug test case. Okay, and the execution has been stopped on this line. I hope that you are able to see that it's red color. And now we can close the REPL and open the debugging window, which is much more powerful. This is DU. And here we can see like what are the variables that are available in the scope, but we can also evaluate some expressions and stuff like this. So let's continue the execution and go inside this function, DSI. And now we can see that we are here, DSO. Oh, wait, sorry, I went too far. Okay, never mind. DSC will continue to the next breakpoint, and we can see the virtual text on the right side here that carries the current value of this variable. This is like this whole debugging capabilities are thanks to the debug adapter protocol, which talks directly. I think it talks with build tool, but I'm not sure. Okay, we can continue the execution. During this debugging, I was hoping that we'll go into actually this function. So wait, I need to recall, I don't have muscle memory without my keyboard. Oh, it's like this. And here, okay. Here we can see that we have a chain of flat maps. So if we want to, for example, refactor it to for comprehension, there is no easier way to do it than to just use metals for it. They provide you with this code action. So I can choose convert to for comprehension, and it will be converted with some generated variables name. I could simply replace them with underscore and this one with unit. Okay. Okay, let's get back to our test case. For that, we can use portals, and portals provide us with this nice way of navigating throughout the recent jump list. So I can get back to our failing test case. I don't have time to fix it, but because this one is a positive test case, in contrary to the rest of the test cases in this file, I would like to be it at the bottom, at the top, and for this, wait, I have callback keyboard. I don't know which letter should I use here. Okay, never mind. But the point is that you can swap regions of your code just as you swap parameters in a class invocation. Okay, and let me quickly check my cheat sheet. Yeah, there is one more thing that I wanted to show you. So you can commit changes directly from Neovim. You can explore the changes you have done. You can stage some of the changes and commit only part of them or all of them. Let's say that this is some VIP. Okay, and now we can, for example, let's say that we want to merge a feature branch into our code base. As you can see, there are some conflicts. So we can get back to Neovim, and we can open div view, which will help us to solve those conflicts. Okay, here we can just accept the changes from the upstream, because as far as I remember, they are okay. So CT, and now let's save it. Okay, I'm running out of time, so let's just close this window. And the last thing that I wanted to show you at the end was the integration of Neovim with ChatGPT, and the thing that I will just tell ChatGPT to rewrite this class, this test cases, into any fun suite, because right now it's using any flat spec. And I would be able to do it directly from Neovim and put this code directly inside this file. However, last night, OpenAI decided to shut down the code edit DaVinci model because they are migrating toward GPT 3.5 and 4. And the plugin, of course, has not been updated since last night, so this part won't work. However, that's not the point, because the point is that Neovim will get AI support for code edition, and actually GitHub Copilot like support Neovim out of the box. They provide you with this Neovim plugin, and yeah, I think that's all what I wanted to show you. Thank you very much for your attention. I hope that it was at least entertaining. And if you have any questions, I will be happy to answer them.
So many questions. I hope somebody will ask about the keyboard.
Not about the keyboard, but I was wondering, because we introduced semantic highlighting recently, is it possible to query it similarly to Tree-Sitter? And maybe is there maybe a project that would join both?
Okay, so yeah, this was one of the things that I wanted to show you, but because of all the issues, I ran out of time. So you can like turn semantic hightings on in Neovim right now. But I think that I need to open this buffer once again. BD exclamation mark. Oh, you see, now we have semantic highlighting, and yes, there is like inspect tree, which allows you to like view the semantic highlighting token that has been assigned to each particular node. However, I don't know if you can query it, but I think that, well, it should be possible. Why not? And it sounds like a cool idea.
Yeah, last question, because we are out of time.
Yeah, yeah, thank you for the talk. I'm just wondering, how long did it take you to arrive to your current setup?
Well, it's complicated to ask because in the meantime, I was also building my keyboard and nixifying my setup and stuff like this. So this whole adventure took me like 2 years, but but there are like frameworks for Neovim that can configure multiple different layers of it for you. And you can have like pretty decent environment with like an hour. To have what? Sorry. Well, yeah, but it's like a Vim emulator, and you cannot really have like all the Vim power Tree-Sitter text objects with something like Vim emulator. Okay, thanks. We can talk later.